Hi everyone, let's go ahead and get started with deep learning with the TensorFlow tutorial. In this we are going to build here a very basic model, and I assume that you must have some knowledge of the machine learning. If you do not have any knowledge of the machine learning, you can visit my channel here at the KGP Talkie. You will be able to see here so many playlists, and you can follow these playlists to learn machine learning in detail. Otherwise, you can follow my Udemy courses as well. So you can visit at KGP Talkie and then you can see the Udemy courses. All right, let's start with this, the process, how we are going to build the model. So first of all, you need to select your data. Thereafter, you need to pre-process the data, and thereafter you can build the model, and thereafter training and estimation of the model will happen. So estimation of model, that means evaluation of model will happen. Basically, you will be testing that how accurate your model is there. So I'm using here a Jupyter notebook, and if you want to set up TensorFlow GPU, then you can follow this playlist. In this playlist, you will be able to see here all these tutorials which you need to follow for the deep learning environment setup. Because GPU installation on operating systems nowadays, like on Windows and Linux, has been really difficult. So you need to follow some of these videos to get it installed. Let's go ahead and try to understand the data set which we are going to use for this tutorial. So we are going to use here Fashion mnist data. This Fashion mnist data contains 70,000 grayscale images in 10 categories. You can see the detail of these images by clicking on this link. I will also share this notebook on my GitHub channel, and you can watch my GitHub repository here. And on this GitHub repository, you will be able to find this. You will be able to find out this notebook. So each of these images have 28 cross 28 pixels. And you will be seeing here all other categories. In fact, those 10 categories which is available here. These 10 categories you can see. Let me just see that. Yeah. So these are the 10 categories. There are t-shirt, tops, trouser, pullovers, dress coat, sandal. Then you have shirts, sneaker, bag, and anklet. So these are labels which is available here. So these are images actually. There are 10 labels where it is written 10 categories. So for our deep learning model, which we are going to build today, we will be passing these images. The size of image is 28 cross 28. And if you multiply this, it will become 700. It will become 784. So either you can pass this as one-dimensional or a single-dimensional vector, or you can pass it as two-dimensional vector. So these are grayscale images. That means there is just a single channel image. RGB images are multi-channel image. That means those are color image. But in grayscale image, you have just a single channel. So it will be having just a single layer of image, that is the 28 cross 28 pixels here. All right, let's go ahead and get started with the coding part. So before we get started with the coding, let me just tell you what are the technologies we are going to use. So we are going to use here TensorFlow. We are going to use here Keras. We are going to also use here Pandas. We will be also using here NumPy. So these are the technology stack which we are going to use in this video. Let me just show you initial level of the block diagram which I'm going to use here. So initial level of block diagram, you can understand like you have image here, and size of image is here 28 cross 28. Then these image will be fed as the input to your CNN layer. All right. And then the CNN layer input shape, so input shape will be there, the 28 cross 28. This is initial level of model. So this will be a 28 cross 28. Thereafter, you can apply there a dense layer. And thereafter again, you can apply the another dense layer. And thereafter, finally, you can apply, a single layer. So that will be also a dense layer, but node will be just a single node. And thereafter, you can apply their activation function. So here you can apply the activation function. So it's like that. All right. So now you see this is the 2D CNN, but we have not learned 2D CNN as of now. So what you can do, instead of this 2D CNN, you can convert this input as the one-dimensional vector. So basically, this input which you have here, this will get converted as this single-dimensional vector. So it's 28 cross 28, and if you multiply these together, it will become here one-dimensional vector with the 784 rows and single column. So what you can do in that case, instead of directly putting this as the 2D CNN, you can put their 1D CNN, or you can in fact remove this CNN at all just for basic model building. You can simply remove this whole CNN. Then what you can do, you can simply put here a one-dimensional layer, and this one-dimensional layer is going to be a flattened layer. All right. So this flattened layer is going to flat this to 784 cross 1 vector. Now it has become one-dimensional vector. Thereafter you need 1D dense vector. Then obviously then again you need here this 1D dense dense vector. Thereafter 1D dense the neural layer. But at the output we will be putting here this is not one. In fact, there are 10 categories. So for 10 categories, you will be needing here 10 dense layers. All right. So I'm sorry, not the 10 dense layer, but you will be needing here 10 cell or neurons. You can say that this is going to be here a cells, or 10 neuron is going to be here in the output cell there. Let's go ahead and get started with the data preparation. So first of all, I import here Keras and TensorFlow. So I write here import TensorFlow as TF. Thereafter, I also write here from TensorFlow. In fact, from TensorFlow import Keras. So once I have imported TensorFlow and the Keras, let's go ahead and download our dataset, Fashion mnist dataset. So that I write here mnist is equal to Keras dot datasets dot Fashion mnist. Just to understand this, let me just show you again here that. So you can just simply run here Keras datasets. So you will be seeing this link. Inside this link, you will be seeing all these links there. So we are using here a Fashion mnist dataset. You just simply click on this. Then this is the the code to download this. So the keras.dataset.fashion mnist.load data. So this particular things we are going to use to load our data. So that's what we are using here. So we have here mnist is equal to keras.datasets.fashion mnist. So that is the mnist function. We have got this mnist function. Thereafter, I write here load underscore data. Once you run this, then you will be able to see this mnist data here. All right. So you have got here mnist data, and you check the shape of this mnist data. You will be seeing there. Okay, so seems like this is a tuple, so we won't be able to see this directly. So this tuple, this is the tuple in the term that this will be returning us these output, these output. So we need to read these basically. So this Fashion mnist data will be returned as the array of input vector and output vector for the training data, and array of input and output for the test data as well. So this is kind of the tuple there. So we need to just copy and paste it here. Thereafter, we can assign this mnist to here. All right. Thereafter, you check this x underscore train dot shape. You should be able to see here 60,000 data points are there, and each data point shape is 28 cross 28. And similarly, you can check for y train dot shape. So in this you will check, you will see here there are total 60,000 rows in this case as well. Let's go ahead and check our Qtrain data. So for one data points, I'm just gonna check it for single data point, and the shape of this data point should be 28 cross 28. So there is 28 cross 28. And you will be seeing there these values varies from 0 to 223, 232 and so on. So how much this maximum value could be here? So the maximum value for 8-bit representation, as you see here, that this number is represented as unsigned integer 8-bit. That means 8-bit maximum value is like how much? It's 255. All right. So you check that max of X_train. You should be able to see that. Okay, let me just import the numpy just to check it. So I write here import numpy as np. Thereafter I write here np.max Xtrain. I get here 255. So this is the maximum value which it can attain, and then similarly you can also write it for minimum as well. So np.minimum, that is the 0. So the maximum and minimum value is there 255 max, and 0 is minimum value which your data set have here. All right. Let's go ahead and see the class names which we are going to, use today. So it doesn't return here the class name. So that is the problem currently. So just to know the class name, and these class names we have to write it manually here. So quickly I'm going to write these here. So I write here class names is equal to top. Thereafter it has here, the trouser. So you will check that this is in, a same order here in the label, the same order of these labels like t-shirt, trouser, pullover, dress, etc. So I write here top, trouser. Thereafter I write here pullover. In the same order I write here dress, and then I write here coat. Thereafter I write here sandal. Then I write here shirt, and thereafter I write here sneaker. All right. Thereafter I write here bag, and thereafter I write here ankle boot. Okay. So these are the class names which this Ytrain have there. All right, or Ytest have. So there are 10 classes. So these classes we are going to use for our training of the data. So you can also check here Ytrain. So you check that the max value will be there 9 because there are 10 classes. It starts with the 0 till 9 there. All right, so you can check the first value like for our Xtrain, that is the 9, and you check this first value for the Xtrain, you will be seeing something like this. But these numbers we can't know that whether it is 9 or not. So let's try to understand that if it is really 9. All right, so for that we are going to plot these values as a matplot figure, and then we will be seeing that whether it is whether it is really 9 or not. So 9 number is ankle boot, so we will be checking that whether this thing represents ankle boot or not. So for that I'm going to first of all import matplotlib. So I write here import matplotlib.pyplot as plt. Thereafter I'm just gonna create a new figure, so plt.figure. Thereafter I write here plt.imshow. So this image is going to show this particular the array 28 cross 28 array now is going to be displayed as the image. Thereafter I'm going to also show here plt.colorbar. So this color bar will make sure that it also represents their color so that we can see that how much maximum value we have here. So this is image, a default image size is like this in matplotlib, and you will be seeing here the maximum numbers are 255. Those are displayed as the yellow color, and this image seems like a boot itself. Now you see there, this is definitely a boot here. So seems like our data is perfectly fine. There is no issue with the data. Now we are going to prepare our data for the model training. So as you know that generally, in fact, in all cases, our neural network works better when our data points are around 0 or mean centered data points, all right, and maximum value is around 1 or so, then our neural network works better. So these input vectors which we have here, Qdrant, the maximum value in these input vectors are quite high here. They have 255. That means we have to normalize this. So for normalization, I'm just going to divide our whole vector Qdrant and Xtest data by 255 so that our maximum value can come within 1. So if you divide 255 by 255, so the max value it can attain there, that is 1. So I write here Qdrant is equal to Qdrant divided by 255.0 so that it can attain there a float value. Thereafter I write here for test as well. So I write here Xtest is equal to Xtest divided by 255.0. Okay, seems like this is not defined. Let me just see that. Okay, so these are written in a small value. Generally these shouldn't be written in small, so I'm just going to change it as the capital letter as of now. Okay, so now you check here this Qdrant. Now these values, in fact first value, so these are now within 0 to 1. So the maximum value is here 1 and minimum is 0. So on this kind of data, generally neural network works better. So let's get started with building our model by keeping in mind this architecture. So we will be following this architecture. So first of all, we need to import TensorFlow sequential, the container. So sequential container is like there is going to be this whole container there. So in that whole container, we will be putting all these layers together. So that is the sequential. In that sequential, we will be putting all these together. All right, so we import that. So for that, I write here from TensorFlow.Keras import sequential. So I write here, the few characters. Thereafter, press tab in the keyboard for the completion. It should be able to complete it automatically. Since I started it first time, so it may take a while. You will be seeing here that it is busy currently. This kernel is busy, so it's going to take a while to complete. That is just the first time. Thereafter, I'm going to do here from TensorFlow.Keras.Layers import flatten layer and the dense layer. So these are the two layers I'm going to import from the Keras layer. As I had shown you earlier, our architecture. So this architecture we are going to follow. So we are going to import, in fact, we imported flatten layer and dense layer. So these are the two layers we will be needing as of now to build our model. So I get my sequential container here, or API you can say. So model equal to sequential. Thereafter in this, I'm going to add first flatten layer. So I write here model.add flatten layer. And for this flatten layer, the shape which I'm going to flat there, I'm going to provide 28 cross 28. So I write here input. Thereafter, I press here tab. Then it should be able to complete it automatically. Otherwise, you can press here shift and the tab to see that input parameters here, right, which it is going to take. So this is going to take input shape is equal to 28 cross 28. So this 28 cross 28 is going to be, so this 28 cross 28 is input image shape. Once you have done this one, thereafter I'm going to add here the dense layer. So I write here model.add, and in that I write here model.add dense layer. Thereafter I write here 128. So basically that 128 means in this I'm going to add here 128 cells there, or neurons. So basically it is going to have 128 neurons here. All right. And thereafter I'm also going to put here an activation function. So in between these activation functions, I'm going to put here, the ReLU activation function. So this is ReLU activation function. I'm just going to put here this ReLU activation function in this dense layer. So in this dense layer, it has 128 neurons, this dense layer. Thereafter I put here activation is equal to ReLU activation. Thereafter I write here again model.add. It's going to have here another dense layer. For that dense layer I'm going to put here 256 neurons, and in that I'm again going to use here ReLU activation function. So now I have followed it for these two layers. So here I put 256 neuron plus ReLU activation function. Thereafter in this I'm going to put here this 10 neurons. Why 10 neurons? Because there are 10 categories. So for each categories you will be needing there a single cell or single neurons there. So I put here again model.add, and in that I put here dense, and then 10 neurons there or 10 cells I put there, and then activation I put here softmax activation. Why this softmax activation? Let me just explain you. Okay, so this explanation you can understand with the, again with this graph. So there are either you will be doing there a binary classification. So for binary classification, you just need a single cell. All right. So for single cell, you apply their sigmoid activation function. But for multi-label, for multi-class, in fact, so there you have more than two classes, something like this, two or more than two classes. So for each of these, you can simply assume that it could be like a sigmoid, hypothetically, or a pseudo sigmoid kind of things. For each of these you need, right? For each of these cells there. But in general, technologically, putting sigmoid is not possible for all of these together. All right. So for this, what you put there a softmax activation function. All right. So once you have something like this, I mean more than two classes, then you will be putting there as a softmax activation function, or you can just make a fundamental that when dense neurons here are more than 2, then you will be using there a softmax activation function. Once you have added this, then you can simply run it. Now you once run this, you can just print your model object here. Once you print this model object, you will be just seeing there some, the memory footprint where it is stored. So you can write here model.summary. You just press a tab, it should be able to complete this. So you run this model.summary, you will be able to see that it has total 1, 2, and 3 dense layer and 1 flattened layer. So this is architecture which we had designed here. All right, so this was the architecture we designed there. And first flattened layer don't have any parameter. That means there is no weights to learn for this. So there is no mathematical operation is being done here. It is just flattening this. Okay, only flattening is happening there. So there are dense layer where mathematical operation is being done. So there are 100,000 parameters for first layer, and then 33,000 parameter for second layer, and then 2570 parameter for the third layer, which is the output layer. And if you combine all these together, that means there are total 136,000 parameter which is going to learn when we train this model. So our model preparation is done here. Let's go ahead and see how you can compile the model. Model compilation is like once you have built your container here, then you have to provide some more parameters to your model or hyperparameters to your model for the training. Like you need to provide their optimizer. So optimizer is like it will tell your model that how to optimize your training, how to make it faster. Thereafter you also need to provide their a loss method there. All right, so the loss method we are going to provide here is sparse categorical cross entropy. Thereafter you also need to provide their metrics which you need to use for your model evaluation. So basically you can say that model compilation so this model compilation needs their some parameters, like it needs their loss function. it also needs their optimizer, which you are going to use. It also needs their metrics. So I write here model dot compile, and then you press here shift and double tab. You will be able to see this whole documentation about model dot compile. So default optimizer is RMS prop. We can use this as it is without any issue, but as of now we are going to use Adam optimizer. A loss, by default loss is none. So loss is something which will be used for your parameter optimization. Thereafter there is metrics. So this metrics will be used to evaluate your model. That means it will be used to compare accuracy, or you can say that how good your model is performing, and rest of other things you can leave as it is. And if you just scroll it a little bit more down, then you will be you will be able to see here, you know, a more detailed argument document here. So it says that what are these loss, what are these optimizers, and how you provide these. Okay, so here I provide optimizer first. So I write here optimizer is equal to Adam optimizer. Thereafter I provide here loss. So in the loss I provide here sparse categorical cross entropy. Categorical cross entropy. Thereafter here is metrics. So there I'm going to use here accuracy metrics. Generally 3 type of loss function is used into deep learning. I mean for classification task in general. Those are binary cross entropy. Then you have categorical cross entropy. Thereafter you have sparse categorical cross entropy. When your outputs are as label, like these are 0, 1, 2, 3, 4 kind of these, then you will be using sparse categorical cross entropy. When your output, now you check your Y-train data. So this output is like this, 0, 1, 2, 3, 4. But when your output is managed as one hot encoded, so basically let me just write it here. So if it is like this, then you will be using this. But if your output is one hot encoded output, then you will be using categorical cross entropy. And if your input is just, I mean target output, so these Y-train value is there just 0 and 1, then in that case you will be using their binary cross entropy. So generally these are, you know, the techniques to select these loss there. Metrics for classification, generally it is accuracy. For regression task, it is MSE, mean squared error there. All right. So we have our model here. Let's go ahead run this one as well. So we have now our model. Let's go ahead fit our model. So the model training is very simple. You can simply run here model dot fit. Thereafter you need to pass here input feature vector, so that is X train. Thereafter you need to also pass here output vector. So this is supervised learning. So this is the target variable Y train, and number of epochs I'm gonna use here some 10 epochs. So I'm going to train it for, you know, the 10 epochs. That's the 10 time the training will happen here. And you press here shift and the tab, you will be seeing here all of the details here. So you can also provide here batch size. So currently I'm not providing any batch size. So if batch size is none, then by default it will be, if unspecified, then it is going to take there a 32. Alright, so basically even though if I leave that, so it will be taking a 32 there. So batch size is like the size of input data, how many input data will be collected together, and based on that optimizer will try to update the weight there. Alright, so that means a 32 image will be taken together, and then using a stochastic gradient method or SGD method, then the direction in which weight need to be updated, that will be identified for the neural network. You just need to simply run this, your model training will start. If you have a GPU, then your model training is going to be a super fast, and otherwise it is going to take a lot of time. So it will take a while. So we have to wait for a while to get it done. So the training has almost finished here. Once model training is done, let's go ahead do the model evaluation. So it is very simple. You can simply do here model dot evaluate. You can just write there model dot evaluate. Thereafter you need to pass here the test data set. So I pass here X test and Y test. Thereafter I just simply run it. So it's going to take a while. Thereafter it says that accuracy, the total accuracy which it is showing us, that is the 88%. All right. And our training accuracy is like 91%. So basically it is saying that our model is overfitting, and that overfitting is the quite less. So we can neglect on given that we have designed here a very basic model. That is the very simple model, and getting this much of accuracy with that model is quite good. Now let's go ahead and see how you can do the classification, how you can prepare the classification report. So for that I'm going to write here ypred is equal to model dot predict. Sorry, this should be here model dot predict. In this I pass here X test data. So now I got here ypred, and if you check this ypred, so it will be something like this. And in this ypred we have to identify that which which level is actually the predicted here, so that you can identify using maximum the value present there. So to get the maximum value, you can simply write there numpy argument maximum. So it will be giving us that the maximum value. So I can write here np dot argmax and then ypred here. All right. And I need to also provide the axis one so that it can do this row by row. So I provide here axis is equal to 1. So now you will be seeing this it is giving us like as y true value or y test value. So now I reassign this as ypred is equal to like this. So now I have y true or y test value and y pred value. Let's go ahead and import metrics from sklearn. So I import from sklearn dot metrics, import classification report, and then inside this classification report I pass here y true value, which is y test actually, and then I pass here y pred value. Let's go ahead and just run this. So you will be getting it something like that, but I'm just gonna do here a print statement so that it can print it as a very nice plot. Perfect. So we are seeing here we have got 89% of accuracy. For some of these classes numbers are coming less. For example, for the 2 numbers are like just 80%, but for like 9, 8 and 7 these numbers are quite high. Then again for 6 numbers are less, so it's a 71, and here for number 4 it is there around 80 there. Alright, so that's how you can build your first neural network. It is pretty much straightforward, and I have explained you this through the architecture by drawing those architecture and how these data flow etc. will happen. I hope that you have enjoyed this video, and if you have liked this video, please like this video and subscribe this channel. And if you have any issue with this, then let me know in the comment. I will try to resolve your comment. Thank you so much for watching this video.